Namaskar and welcome back to another lecture on this course on Introduction to Infrastructure Asset Management being offered under the MOOCs scheme and initiative of the Government of India. We are today in the fourth lecture of the first week and we will talk about basic economics for infrastructure management. Before we move forward, there is just a statutory kind of a warning that the material used here in the course is strictly for academic and instructional use, and it is not expected that you will use it for any other purpose. Make it a habit to make the screen a blackboard and make notes as usual and then study. To recap what we have been doing in this course, we talked about the conduct of the course, we talked about the fact that infrastructure is basically characterized by massive investments and has a very long service life. The infrastructure could be in diverse environments and therefore subject to diverse conditions which would cause damage over time due to this exposure. We discussed the concepts involved in the variation of deterioration and of performance over time along with the relevant keywords from the point of view of maintenance and management. We also made an attempt to define service life in the context of critical levels of performance and or deterioration. We talked about the fact that the process of deterioration cannot be lost sight of in a comprehensive approach to asset management. Moving forward, what we will talk about today is something very different. We will talk about relevant concepts of economics using a representation of a cash flow diagram. Then, through illustrative examples, we will discuss the difficulty in extending these concepts in evaluating infrastructure projects and their management. So, now to introduce the topic to you, value is created if the investor earns more than the investment cost, which means that the earning and the cost have to be somehow brought to a common denominator and there has to be a common currency in which they can be evaluated. We will talk about this more later on, and the selection of a project should be such that the project should not only create value, but it should create value greater than any other investment with a similar risk. So, what is being said here is that investments are subject to risk. There is a certain amount of uncertainty when we make an investment. It is much more so when we are talking of long durations, 50 years, 100 years, maybe even more sometimes. Focus is shifting to analysis of overall life cycle cost of the project in evaluating investment options. And then the value of an investment or a project depends on the amount of cash flow expected from the project, the timings of these cash flows and the uncertainty and the risk associated. Remember that we are talking of cash flows. Cash flows have two basic components. One is revenue, that is, something is earned by somebody, some cash flow happens that is positive, and then there are expenses, and that is a negative cash flow, somebody spends some money. Having said that, it is also true that what is an expenditure for me as one part of the infrastructure project or as one stakeholder in the infrastructure project could be an earning for somebody else. That is something which we need to understand and keep in mind when we draw cash flow diagrams. We will try to see some examples today. Yet another concept which is very important when we are evaluating projects and investments over a long period of time or even a short period of time for that matter is the concept of time value of money. The worth or the value or the purchasing power of $100 or 100 rupees today is not the same as it was, let us say, 50 years ago or 100 years ago, neither will it remain the same over the next 50 or 100 years. We often hear that our forefathers, for example, they earned only 50 rupees a month, whereas the salaries of the same kind of a job now would be maybe several thousands. But was the purchasing power of the 50 rupees the same as the purchasing power of 50 rupees today? No. So that is what is, simplistically speaking, the concept of time value of money. How much is the value of money going to change? And one way of representing it is through the interest rate. As I just said, the value of money changes with time due to different reasons or factors. Inflation is one of them. Interest, as I just mentioned, represents the earning power of money and can be looked upon as the premium paid to compensate the owner for the loss of use of the loaned or invested money. We deposit some money in the bank. The bank pays us some interest. Why? Because we have foregone or given up our right to use that money at a certain point in time, and therefore the bank pays us some money. That done, the bank lends that money to somebody else to set up an industry, to have a startup, and so on. And then those people have to pay an interest to the bank, because now the bank has organized that finance for them. So financial decision making or interests paid, these are important considerations when it comes to handling infrastructure projects in their management in a comprehensive sense. So far our discussion has been largely on technical grounds. Now today we are introducing this concept of economics and finance, and that's something which we'll talk about in greater detail as we go along in this course. Therefore, there is obviously the concept of a present value and a future value for any investment. Moving forward, let's look at what we call cash flow diagrams. Now, a cash flow diagram is a visual representation of the inflow and outflow of funds. Those are either received or spent during the project's lifetime. This is an illustrative example. The convention we have followed is that the inflow is positive and the outflow is negative. That is, this part here is the outflow, it's like expenditure, and it is shown here, that is below this line, which is typically designated as negative. And this side is the revenue, which is inflow, and that is designated as positive. So, this is the kind of convention that we followed. And what does it show us? That okay, here is an investment or a project that requires 10 lakhs or a million rupees at time t is equal to 0. That is, we make an initial investment. Somebody makes an initial investment. It could be a bank, it could be a financial institution, and so on and so forth. Now, what are the returns of this? At the end of 1 year, you get 2 lakhs. At the end of 2 years, you get 50,000, 3 lakhs here. You spend some money again, 50,000 and 1.5 lakhs here. In years 4 and 6, you earn something here, you earn something here. Now, if this was known to us, the question will be, is this investment advisable? That's a simple question that we need to answer. Now, before we proceed to analyze this cash flow diagram and answer the question of whether or not this investment is advisable or not, I would like to clarify one more thing. That is, what we've talked about here is a large sum of money invested in a single go, and these values are all coming out at different points in time as some amount of money. Now, instead of this, it's always possible that over a period of time we make certain investments. These need not be constant, they could be growing over time. And then of course, on the revenue side as well, it is not necessary that everything will be a certain number here. It could be distributed over a period of time. We are all familiar with situations such as a recurring deposit in the bank. What happens there? We make some deposits every month or every year, whatever we do, and at the end of the so called maturity period or whatever, we get a certain amount of money back. That is our income. So, this is our expenditure. So, instead of a simple deposit here giving me some amount here which includes the interest, here we have distributed our expenditure or distributed our deposits, and we get a certain sum at the end of it. The matter could be more complicated in the sense that there is a distributed investment with a distributed revenue, and then we have to make a decision. So, all these variations make it important that we understand or have some concept of modeling this cash flow diagram and making simple decisions or having a mathematical model which will help us make quantitative decisions. And these models that we have are single payment based, that is compound amount factor or the present worth factor, or it could be equal payment based, where we talk about a compound amount factor or a present worth factor, sinking fund deposit, capital recovery factor, and so on and so forth. It is not the interest or the intention of this course to make you an expert at understanding or analyzing these models. The idea is only to ensure that you have some understanding of what goes on at the back end when certain decisions are made. Now, to explain some of these ideas here in single slides, what is a single payment compound amount factor? What it basically says is that what is the F given P, I and N. What are P, I and N? P is a certain amount of money invested at a certain point in time. What is I? I is the interest rate, and N is the number of years. Now, we all know that if this was the case, then we are talking of the amount at the end of n periods, rate of interest being I, given that the principal was P. So, given P, I and N, what is F? So, that represented as 1 plus I to the power of N. As an example, if we deposit 10 lakh rupees, what would it grow to in 5 years if the rate of interest is 8%, assuming that the compounding is being done annually. So, we know how to calculate this number, and how to calculate this number if the compounding was being done in 6 months or in 3 months or every month, and so on and so forth. So, that is something which we have already known. The other factor that we talk about is the single payment present worth factor. This is only the problem that we discussed just now, looking at it the other way around. Given the F, what should be the P? That is, given F, I and N, what should be the P? So, if we want a certain amount of money at the end of a certain amount of time, assuming that there is a certain amount of interest involved, what should be the present investment or what should be the present value? So, in a manner of speaking, what is being said here is that what is the present worth of this F? So, this F, for example, we want 10 lakhs at the end of 5 years, assuming that interest rate is 8%. This amount is not 10 lakhs today. So, what is the present worth of that 10 lakhs? So, that is done using this kind of a factor, and that is what is illustrated here in this example. What it says is that if we want 20 lakhs at the end of 10 years at 10% interest, what we need to do is just invest 7.71 lakhs. So, basically what is being said is that 7.71 lakhs today will be worth 20 lakhs at the end of 10 years, and that is why this factor here is called the single payment present worth factor. Moving on, when we talk of equal payments involved, then we have several factors coming in. Equal payment compound amount factor, which basically says that okay, if we make this A n years, interest being I, what will it grow to? And here is the mathematical representation of this factor. So, if we say that okay, what is the worth in INR at the end of 10 years for an ordinary annuity of 20,000 INR operated at an annual compounding rate of 8%, the answer is this. That is 20,000 invested for 10 years will give you 2,89,732. So, basically what we are doing is that 20 lakhs over 10 years is 2 lakhs. Now, 2 lakhs is the total investment being made, and each of these smaller amounts will earn a certain amount of interest over varying periods of time, and then if we sum it up, we get this amount here. That is, the total interest earned on this investment is 89,732. So, that is how we look at the equal payment compound amount factor. The next factor that we are going to talk about is the equal payment sinking fund deposit factor, which is given F, what should be the A? That if we want this F at the end of n, assuming I, what should be the A? So, here is the mathematics of it, the arithmetic, which tells you that okay, this will help you come to that factor. The importance of all these factors is that once we know these factors, then we just need to say okay, if we have any amount, we just multiply or divide or whatever we do with these factors, and we have our answers rather than having to do the arithmetic all over again. As an illustration, how much should be invested in a bank every year to make a sum of 20 lakhs at the end of 20 years? So, the answer is only 43,705. So, if you invest 43,705 every year for 20 years and the rate of interest was 8%, it will grow to a total value of approximately 20 lakhs. Now, equal payment present worth factor is just the same problem stated the other way around, that if this is being done, then what is the present worth of this investment? Please note that for a sufficiently large n, this factor or this expression tends to become 1 upon I, and I do not want to do the mathematics of it. It is very simple. We will not do mathematics unless it is very much required. What is very much required is for you to understand that okay, there is a formula and it can be used to get the results. The illustration for that is, what is the present worth of an ordinary annuity of 20,000 invested for a period of 10 years and being operated at an annual compounding rate of 8%. So, the answer is 1,34,000. I leave it to you to think what is the importance of this factor or this diagram here in the context of infrastructure projects. And the last factor that we promised to talk about is the equal payment capital recovery factor, where we are talking of what is the A if we know P, I and N, and this is the expression. The illustrative example could be that what should be the annual installment for a period of 6 years that a lender has to fix to recover a total amount of 2 lakhs at an operating interest rate compounded annually of 4%. So, this is what the number is. I am also leaving it to you to think about EMIs in this context. It is not really this picture alone. We often take loans from banks, maybe 1 lakh, maybe 2 lakhs, maybe 10 lakhs, whatever it is, and then we repay that loan in EMIs. And what is the importance or what is the significance and how those EMIs are calculated. The EMIs, if you just total them, the total amount will obviously be more than the loan that you take, and that difference will grow as the period of the loan increases. If you have taken a loan for a longer period of time, you will end up paying more money, and that is what we need to understand in the context of this discussion that we have just had. Now, moving forward, we come to economic decision making. Now, so far what we have done is learnt a few tools which will help us make these decisions. Now, when it comes to economic decision making, it involves cost comparisons between alternatives. For example, if we consider two projects A and B, project A has high initial cost and low yearly maintenance, whereas project B has low initial cost but high annual maintenance. Being an investor, which of these projects should be chosen? Now, in order to do that, we need to make a decision. So, some of these decision making tools that we use are a payback period, return on investment. These two do not consider the time value of money. There are several others which actually consider the time value of money, and that includes discounted payback period, net present value method, internal rate of return method, equivalent annual charge, and benefit cost ratio. These methods consider the time value of money. Now, to very quickly go through some of these, as far as the payback period is concerned, it is the simplest and it is the time period in which the investor gets the investment back. No time value of money is considered, and out of the various alternatives, the project with the shortest payback period is preferred. As an example, if we look at two alternatives A and B, the initial investment for both of these projects, let us say, is estimated to be 50,000. Project A is estimated to give 10,000 a year for the first year, 20,000 in the second year and 15,000 for the next 4 years, whereas for project B it is expected that it will yield 10,000 over 6 years here, whereas for this project A, it is 10,000 in the first year, 20,000 in the second year and 15,000 for the 4 years. Now, we could be tempted to make cash flow diagrams and say that, okay, the total returns of the project or from the project are more in the case of A, and therefore, we simply go for A. But that is not the approach that we adopt for this method, where we are talking of the payback period. So, we construct the cash flow diagrams for A and B, that is, for project A and B, we have an initial investment of 50,000, we have 10,000, 20,000, 15,000 for all the remaining 4 years, 10,000 across the board for the 6 years, and the payback period for A is basically when do we get this 50,000 back. So, as far as getting the 50,000 back in option A is concerned, this is 10, 20, that is 30, here it is 45. So, at the end of 3 years, we have already got back 45,000, and at the end of 4, we will get 15, but we are only interested in getting 5,000 out of it, and therefore, we calculate the payback period as 3 years and 4 months for A. In the case of B, the answer is very simple. The 50,000 comes back to us in 5 years. Now, therefore, the payback period for A being smaller than the payback period for B, A is the preferred option. Moving forward, let us go to another parameter, return on investment, ROI, which I have simplified as far as this discussion today as average return on investment. Now, as the name suggests, it is a measure of how much is the return or profit made on an investment without considering the time value of money, as against the payback period, which is the time in which the investment is recovered. The ROI considers the full return and evaluates it with respect to the initial investment. So, now let us look at this example which we just solved with the payback period approach. We had two alternatives A and B for a company. The initial investment in both the projects is estimated to be 50,000. Project A is estimated to give 10,000 in the first year, 20 in the second, and 15 in the next 4 years, whereas project B is expected to give 10,000 for all the 6 years. So, what we are doing now is to talk about this example in terms of return on investment in the two cases. We already know that this is what the cash flow diagram will be in projects A and project B. So, if we look at the total returns for project A, we find that it is 10, 20, 15, 15, 15 and 15, and the number is 90,000. For project B, the number is 60,000, 10,000 for 6 years. In this case, for simplicity, I have kept the duration for both these options to be 6 years. Now, with this input, we know that the net returns on A and B are 40,000 and 10,000 respectively. After all, we invested 50,000 in both cases. In one case, we got 90,000, though it was over a period of 6 years. And the next case, we got only 60,000, again over the same period, and therefore, the net returns are 40 and 10, and we can therefore calculate the ROI in terms of percentage, which is 80% for case A and 20% for B. Obviously, we would prefer investment A. Now, the question is that if these numbers were to be slightly modified, then the payback period will change and also the return on investment. The return on investment, which is mentioned here 80% and 20%, is not for 1 year. If we want to calculate the annual average rate of return, then in case A, it's probably close to 13.3%, in case B, 3.6%. The issue is that this is an illustrative example to show how these calculations are carried out. If I had changed the duration over which the income or the returns are accruing in project A and project B, then obviously the numbers will change. And it's an exercise to you. What I'd like you to do is to see if through changes in the values of the cash flow diagram, is it possible that the payback periods and the ROIs or the average ROIs that we've talked about here yield different options for a preferred investment. Recall that even when we are talking of the payback period, the option A was preferred over option B because the 50,000 is getting recovered in the case of A in just more than 3 years, whereas in option B it is pretty close to 5 years. In this case, therefore, the way the example has been given, both the average ROI and the payback period point that option A is the preferred option. But if I change these numbers, then is there a possibility that the payback period and the ROI, they give you different suggestions or different recommendations? So, basically the idea is that these parameters, whether it is payback period or the ROIs or other parameters that we are going to talk about, which consider the time value of money, are they absolute in terms of their recommendation? Do they give you a very unique recommendation? The answer is no. The answer is that each parameter gives you some number, and it is up to us to decide which of those parameters is more suitable to the kind of condition that we are dealing with. Especially, for example, when we are talking of infrastructure projects, which is the issue as far as this course is concerned, then we cannot be talking in terms of 6 years or 7 years or even 10 years. We cannot be talking in terms of a single investment. There will always be expenses which may occur at different points in time. These are the kind of considerations which we have to have, and also the whole idea of the time value of money. If this period of 6 years was, for example, 6 months, then the kind of difference that it makes in terms of whether we consider the time value of money or we do not consider the time value of money, the difference is going to be marginal. Therefore, a simplified approach which does not include time value of money would be enough. But if we talk in terms of longer term investments, then obviously we need to talk about the time value of money included. Let us try to see some examples and parameters with the time value of money included in the subsequent discussion. Now we come to parameters where that time value of money is accounted for, and one of them is the discounted payback period. Now, this is nothing but the payback period itself, except that the time value of money is taken into account. For the example discussed, to illustrate the payback period, calculate the discounted payback period by assuming a discount rate of 10%. Now, this is something which is being left to you to do as an assignment. We already did an example for the simple payback period, and what is being left to you is to calculate the discounted payback period assuming a discount rate of 10%. The next parameter that we talk about is the net present value. What is NPV? NPV is the sum of all cash flows discounted to the present using time value of money. CFT is the cash flow at year T, N is the life of the project, and K is the interest rate. Then all these CFTs are brought to their value at time t is equal to 0. That is what is illustrated here. NPV is evaluated at time t is equal to 0 for all these CFTs. The overall NPV is the sum of the NPVs of all the individual CFTs. In other words, each CFT is being brought to the present value, and then finally we sum up all the present values. Note that we are using this factor 1 plus k to the power of t. I am leaving it to you to relate this part to the factors that we talked about a couple of slides earlier. Now, if NPV is greater than 0, then the project creates value to the investor and is a preferred investment, and if it is less than 0, it is not a preferred investment. So, as an example, if the cash flow projections for a proposal are shown in the table given below, what we are required to calculate is the payback period and the NPV of the cash flow at a certain interest rate, and also suggest whether the project is worth executing. Now, if this was the information known to us, that is, we have an initial investment of 2 lakhs and it yields 35, 37 at the end over a period of 7 or 8 years as given here, then we want to use payback period and trying to find out the NPV from the cash flow diagram with an interest rate. This is the cash flow diagram. Here we have the investment or the expense from our point of view, and this is the revenue. Now, as far as the payback period is concerned, from this diagram, we want to calculate the period where 200 is recovered. Remember that the payback period does not account for the time value of money. That would simply be 5 years, 9 months. Now, let us calculate the NPV with an interest of 10%. So, what we need to do is to copy this part of the table here and just make a note of these factors, which is nothing but the discount factors that we talked about a couple of slides earlier. So, basically what is being done is that this 35, what is the present value of that 35? Now, since it is year 1, the value is 31.81. If it is year 2, this value goes on reducing, because these smaller amounts will grow to this amount a larger period of time. That is why these amounts are smaller, given the fact that these amounts at the end of that period are fixed. Now, if we do that, the net present value turns out to be minus 12,345. If we repeat this calculation at different interest rates, we will get some very interesting results, and that is something which I am leaving out to you to do. So, instead of 10%, try to do it for another interest rate and see how does the NPV change. Well, even though I said that I am leaving it to you to do it, I am showing it to you for 5%. You could always do it for other interest rates, and if the interest rate was 5%, these values here would change, and so also would the NPV. So, in this case the NPV turns out to be plus 22,129. What do we notice? That the sign of NPV has changed once we change the I, that is the interest rate. The previous rate was 10% and then it was minus 1, 2, 3, 4, 5 or something like that. Now at 5% it has become plus 22,129. Now I am leaving it to you to do the verification of these numbers. Maybe they are not most accurate, but the principle is that yes, the NPV changes as the interest rate is changed. And this brings us to the important concept of internal rate of return or the IRR. Now IRR is the discount rate at which the NPV of the cash flow is 0. So NPV will become 0 or will be 0 at a certain interest rate. What we saw last time was that at 5% it was positive and at 10% it was negative. Now between these 5 and 10 obviously then there will be an interest rate at which this will be 0 and that will be the IRR for that investment. Mathematically the IRR is shown here, where CFT is the cash flow at year T and N is the expected life and so on and so forth. Without explaining this in any more detail, I will leave it to you to just study the fact that NPV is a function of the interest rate and try to find out this value for a couple of other examples also, not only the one that I gave you. Try to make it more complicated by saying that okay, if instead of a single investment here and then having equal or more or less equal revenues, if this became different, then what will be the NPVs at I1, I2, I3 and so on, and at what I will the NPV be 0. So if you do that, you will have a lot more confidence in saying that okay, here is an investment scenario and this is the internal rate of return. Now an alternative with a higher IRR is preferable as far as the investment is concerned. One of the last factors that we need to briefly talk about is the equivalent annual charge, and this distributes the present value of the project equally over the life of the project and is evaluated in this manner, and in a manner of speaking is nothing but the capital recovery factor. Moving forward, we can talk about the benefit cost ratio. This is the ratio of the present value of cash generated, which is PVG, which is the generated part of it, to the present value of all the investments made, that is I. So this I here is investment, this G is generated, and what we are talking about is the present value of the investments and the revenues. So it is evaluated as given here, that is the PVG is the sum of all the generated numbers, that is all the numbers where the generation is happening and summing them, whereas the investment is also a sum of all the investments being made and being reduced to the present value. Now if this ratio is less than 1, the investment is rejected, and if this ratio is greater than 1, the investment can be recommended. What's really being said is that if this ratio is less than 1, what does it mean? That is, the PVG is less than the PVI. That is the situation, that is the condition when the ratio will be less than 1, because we are talking of a ratio of PVG upon PVI. If PVG is less than PVI, the ratio will be less than 1, and if PVG is greater than PVI, then the ratio will be greater than 1. And what that means is that the value of the generation is less or more than the value of the investment. So if the value generated is more, it is good. If the value generated is less, it is not so good. Now the question is whether the generated cash and the investment which then also has to be in cash? Can all generations, that is the revenues and all the investments, can they be reduced to cash values, especially in the case of infrastructure projects? So, this brings us to the second part of our discussion, that is whether all this discussion that we have had so far in terms of the different factors that we use and the different parameters that we use for decision making, how relevant are they from the point of view of infrastructure projects. So, let us briefly talk about that part, that is evaluating infrastructure projects. We look at this simple cash flow diagram and we discussed it enough earlier. The question that we have is, are these numbers certain? That is this 10 lakh a fixed number? How sure are we that these numbers will be what they are? And this investment will be 50,000 and 1,50,000 as shown here. After all, we are talking of a period of 7 years. In fact, in the case of infrastructure projects, this number could be much larger, and we are talking of longer projects. And in that case, there is no way that we can be absolutely sure of these numbers. The second thing is that, is everything really monetizable? Can we talk in terms of investments and revenues in terms of cash? Of course, we must make an attempt to monetize them, to reduce them to a single common denominator, so that a fair comparison can be made. But is it really possible to do that? Sometimes we do things which are not necessarily very logical in a very scientific sense of the word, but that is what is the whole problem or the whole interesting part of management, where we try to work in an uncertain environment and we try to make assumptions and come up with models to make decisions which may be right or wrong. The only thing we have to understand and keep in mind is that the decisions made for one project, the errors therein need not be repeated in further projects, and that should be the essence of our discussion as we move forward. As an example, let us talk of a highway project. Now, in the case of a toll highway project, there is a certain amount of time where there will be planning and design activities, certain amount of expenditure will be incurred. After this, we will start the construction phase, where some more expenditure is going to be incurred. And this, after all, is only the estimated construction cost. We all know that this estimated construction cost is not necessarily a very sacrosanct kind of a number. We often hear that a project which estimated cost was 10 crores or 100 crores was completed at 1.5 times that value and so on. What happened was, this estimated construction cost changed. Now, why it changed and so on is not at all the subject matter here. Now, coming to the revenue side, after this highway has been built, only then we can have some revenue coming in by way of toll. So, we can have projections which will tell us that as time goes on, more and more revenue will be generated. Now, this revenue is a function of the number of vehicles that use it and the toll per vehicle that we impose. Now, this number of vehicles is something which transportation engineers can help us predict through models, that okay, if on this sector we have a certain amount of vehicles plying today, over a period of 5 years, 10 years, 20 years, what is the likely growth in terms of the number of vehicles? This toll that we use is a different decision. We may charge a toll of 40 rupees or 50 rupees or whatever number today, which may change over a period of time. As the period changes, the toll changes, the number of vehicles will change, and at the end of it, talking of only a projected revenue. Remember that during this operation and maintenance phase, there will also be projected operation and maintenance expenses. And we will need to maintain and repair the road, we will have to maintain the toll plazas and so on and so forth. So, there will be a certain amount of expenditure which will be continuously incurred as far as operation maintenance is concerned. So, the net revenue that we have is only the difference of these two. So, taking a difference of these two is perfectly fine, but I hope you have enough understanding of the fact now that these numbers which are projected revenue and projected operation maintenance cost, these are only estimates, which means that the numbers that we use to carry out, let us say, the NPV kind of analysis for this road project will have a certain amount of uncertainty. And that is what is represented here. That is, if the vehicles grew at a rate higher than what was projected, we will have a revenue excess. But if the vehicles did not grow, then we can have a revenue shortfall. And this difference here, which is basically, let us say, an optimistic estimate of the revenue and a pessimistic estimate of the revenue, that can go into some kind of revenue uncertainty. Similarly, there will be uncertainty as far as the operation maintenance cost is concerned, and we have already talked briefly about the uncertainty in the cost estimates during construction. That is, we started with this, we might be able to complete it in this level, or we may land up going to this level. Please remember that these diagrams are not to scale and only schematic in nature, and I must thank Tejas Gupta, one of my students, who helped me create these diagrams. Now, let us take another example of a manufacturing unit. If we set up a manufacturing unit, it involves capital expenditure in setting it up and operational expenses, which could be raw materials, salaries of employees, maintenance of that unit and so on. It will have revenues which will come from sale of the product, and then there will be direct and indirect employment generated as a result of setting up of that unit. Similarly, there will be an improvement in the local conditions, CSR or whatever we call it. The fact is that if this unit is set up, it will require raw material which was not being consumed. So, to produce the raw material, some other industries or some other units will be set up, and that is what is being referred to in terms of indirect employment generated as a result of setting up of this unit. And therefore, it is not so easy to just evaluate the impact of setting up a manufacturing unit. So, as far as this manufacturing unit is concerned, surely we can draw a cash flow diagram, whichever way we want. That is, we make an investment, and because of the sale of the product, a certain amount of revenue is generated. But what happens to this indirect employment generated? That is something which is missing when we do a simple analysis, which is something like this. The problem becomes even more complicated when we talk about infrastructure projects, because in that case too, there is a capital investment in setting them up and operational expenses in terms of maintenance, salaries and so on and so forth. Now, when it comes to revenue, the problem is that there is no product to sell. The bridge does not have a product to sell, the road does not have a product to sell. Yes, we can, in the case of roads at least, we can talk in terms of the toll collected. So, that to some extent is easier, but then all roads are not toll roads. There are roads where there is no toll. In that case, what happens to revenue? Now, let us talk about infrastructure projects a little bit. So, for these projects such as highways and so on, we often hear that they will spur development, they will provide better and more employment opportunities, they will reduce the journey time and facilitate movement of people and materials. Now, that is something which is specific to highways, but any infrastructure project we can talk in terms of spurring development or bringing about development, improving the living conditions of the people, providing better employment opportunities and so on. And it is important that such statements are quantified and a quantitative assessment be made of the impact of infrastructure projects. It is difficult. It is not necessarily a comparison of one value versus another value, but that is what must be done. It needs to be done, and actually it is done. So, my question to you is, what are some of the parameters that can be used for quantification of the impact of infrastructure projects? And what are some of the parameters of development? We talk about development, we talk about infrastructure projects. So, how do we measure development? How do we say, for example, that India is a developing country? The West is a developed area or a zone. What are the parameters that can be used to define this whole idea of development? Similarly, as far as infrastructure projects are concerned, what are the parameters that can be used to quantify their impact? There may be errors. The whole treatment may not be very logical, but that treatment has to be made in order to be able to make an assessment, and that treatment needs to get refined over a period of time. So, these are some of the things that we will talk about in later parts of our discussion in this course. Now, with this, we come to an end of our discussion in this week, where we have talked about what infrastructure assets are. We have talked about performance of those assets, either in terms of performance parameters or deterioration parameters, and we have talked about the importance of maintenance to keep, preserve and protect. Our agenda for the next module will be to talk in terms of life cycle of these assets and the stakeholders involved. This we will do using some case studies, not really case studies in the absolute sense of the word, but some discussion of different projects or different infrastructure, which we would use to bring out the importance of concepts of life cycle, keeping all the stakeholders on board all the time, and having a rational maintenance procedure. And before we close, I will share with you a list of references or material for further reading, which will help you understand the subject matter covered today and being covered in this entire course. With this, we come to an end of our discussion today, and I would like to thank all my teachers, colleagues and students who have helped me understand infrastructure creation and maintenance, and my slides have their input in different ways, and I am indebted to them for all their permissions, encouragement and so on. Thank you.